statistics unit. So just so you guys know, statistics is the study, analysis, and interpretation of data. Now, there's a lot of degrees in statistics. If you go into statistics, it's a certain branch of math, very different than math that we're used to, but it's really cool. I know that Vivint recently hired a bunch of statisticians to come and work for their company to analyze and interpret data. They're getting paid big bucks, people. Anyways, there's a lot of places where statisticians are hired, so you could go into statistics in your future. Okay, so there's a number of statistical ways to describe and compare sets of data. And today we're going to be comparing sets of data by measures of central tendency. So today we're going to be focusing by comparing the data by measures of central tendency. So a measure of central tendency indicates the middle of the data set, which makes sense. The measure of central tendency, once again, indicates the middle of the data set. We usually look at measures of central tendency by mean, median, and mode. These are all ways of looking at the middle of the data, but just in different ways. So you have to remember what each of these things mean, because they mean the middle in a different way, or what occurs most often, or the average-ish. So mean is average. So the way I like to remember that is because these used to blend in my head, even when my first year of college, when I was taking calculus-based statistics. I was like, okay, what's mean again? So here's a little thing to help you remember. If you said to me, Miss Christensen, do you think I'm a good student? And I said, you're average. That'd be a mean thing to say, right? If you called me an average teacher, I would think that's mean. So mean means average. Are you guys, that's a stupid little thing to help you remember. Once again, if I said you're an average student, that's kind of mean. So mean means average. So you know to find the average, to find the mean. And you're going to see some new notation in secondary 3. X bar just means mean. So it's just the notation you'll have to get used to in secondary 3. So X bar just means mean. To find the average, you sum up the sum up the terms, right, guys? And then you divide it by the total number of terms, right? So if I had 180, we would sum those up, right? Divided by 2, what would we be at? 90, right? Right, guys? 180 divided by 2 is 90. Halfway between. Do you see how 90 is halfway between 80 and 100? Okay, sweet. Median means middle. This is the way I remember median. Because if I say find the median, you have to know what it means. It means the middle number. Median of a road, right? Isn't that always in the middle of a road? The medians, and you know what I mean? Splits the middle, okay? So median means middle, and to be able to find the true median, your terms have to be in order from least to greatest. So for example, 2, 4, 7, it's in order from least to greatest. 4 is the middle term. Does everybody understand? Because there's 1 on this side, right? And there's 1 on this side, so the middle one would be 4. Is everybody good? Now to find the median where there's not an exact median, such as 3, 4, 5, 6, 1, 1, and then look, don't these split the middle? So you would add those up, you would find the average of those, so 4 plus 5 divided by 2. Does everybody understand? Okay? Mode means occurs the most. So it just sounds just like it said, mode. It occurs the most. So for example, in 2, 2, 3, 4, the mode would be 2 because it happens the most times. Does that make sense? Mode means most, where it happens the most. So if you have 2 modes, such as in this set, 1 happens twice, 3 happens twice, it's considered bimodal. If there's more than 2 modes, statistically, they won't make a significant difference. So if there's more than 2 modes, you wouldn't consider there'd be no mode. Does that make sense? Okay? So if there was 4, 4, then we would say no mode. There's too many alikes. Does that make sense, everybody? Do you get what I'm saying? Okay. All right, so once again, the mean, median, and mode are the most commonly used measures of central tendency. Okay, so let's answer this question. It says, the frequency table shows the number of job offers received by each student within 2 months of graduating with a mathematics degree from a small college. What are the mean, median, and mode for the job offers per student? So let's go through and find each of these things really quick, guys. Mean. Mean means what? Average. Don't we sum them up? Divided by the total number. So now look. Job offers and students. So 0 job offers for 2 students, right? 1 job offer for 2 students. 2 job offers for 4 students. 3 job offers for 5 students. So to sum this up, wouldn't we go, and then it continues, wouldn't we go, okay, so there was 0 times 2, right? plus, because there's, okay, so I was thinking that this would make sense, but couldn't we go like this? How many times was there 0 job offers? Right? How many times was there 1 job offer? Do you get what I'm doing here? So how many times was there 2 job offers? But I don't want to have to write it out like that, so I'm thinking about it. When we are adding these up, isn't it repeated addition means multiplication, right? So 0 times 0 is the same thing as 0 times 2. Okay, so then plus 1 times 2. Does that make sense? Okay, and then plus, so there was 1 job offer 2 times. And then there was 2 job offers, how many times? Are we all comfortable with what I'm doing? Do I need to write it all out? Okay, and then plus 3 job offers 5 times. And then there was 4 job offers 2 times. And then we're dividing that by the total number of terms here, right? So how many total? Let's add it up. 4, right? So let's see here. Oh no, we're adding up this, right? So 2 plus 2 is 4. Plus 4 is 8, right? Plus 5? 14, 15. Right? Because if we were to keep writing this out, wouldn't we have 15 terms? Okay, sweet. Go, tell me, what is it?
2.2.
It's 2.2? So, an average of 2.2 job offers once you leave this college. Does everybody understand that? Okay? And then our median. Median means middle. So let's think about this, guys. Median means middle. There's 15, right? So there's a couple different ways. Some of you aren't going to be comfortable with thinking of it this way. You'll have to write it out, but a lot of us will be able to. So that it is in order from least to greatest, correct, everybody?
Yeah.
Okay, so I'm going to try to hopefully make this make sense. So if we go 2 in and then 2 in, wouldn't that be 4 in? I'm trying to find the middle here. So then 2 and 5. If we went 4 in, then we would be, we still have 1. Or let's see, 2 plus 2, we'd have 3, right? They are in order from least to greatest.
No, because there's 2 of them.
But this is what would be listed out, right?
Oh.
So if this is going to be too confusing, we can list it all out.
It's 2.
Is it too confusing for you guys to think it
Well,
about it?
I thought we were.
Because that's fine. I can write it out.
The bottom.
We're finding the media of the data set, which is this.
Yeah.
Okay. What? Okay, so let's see. Okay, so this would be in 5, 6, 7, right? If we were going in 7. So this is in 4, right?
Yeah.
So then would it be going in 3 more, put us in this vicinity of 2? So then there would be 1 left, right? So that would land on 2. If that doesn't make sense, let's just write it out. 0, 0. How many 1s are there? 1, 1. How many 2s are there? 1, 2, 3, 4. How many 3s are there? 1, 2, 3, 4, 5. How many 4s are there? 4, 4. Okay, so let's go backwards. I'm going to cross these out. 1, 2, 3, 4, 5, 6. And I'm going to go this way. 1, 2, 3, 4, 5, 6, right? Let's make it even. 1 more on this side, 1 more on this side. You see how we landed at 2? It's our median, people. Okay. So our median's 2, and then our mode happens the most. Which one? 3, right? Most people were offered 3 jobs, right? Everybody? 5 of them were. Okay, so our mode is 3. Does everybody understand how to do this? Okay, so do 1 through 3. Okay, guys, so now we have to know what an outlier is. So an outlier is a value that is substantially different from the rest of the data in a set. Once again, an outlier is a value that is substantially different from the rest of the data in a set. So, once again, guys, if a data is in one variable, outliers can affect the ends. They occur at the ends. So, because it's an extreme, right? It's extremely different than the other data points. Does that make sense? An outlier is a value that's very different than the other values. So wouldn't that be somewhere on the end? Either substantially smaller or larger, right? Something that stands out. And they can be misleading because they can affect the measures of central tendency. So an outlier, I like to call it an outright liar. And here's why. Because it will affect your measures of central tendency because they're so extreme. So here's an example for you. This is a dumb example, but it's actually kind of good. So let's say, for example, I have 3 students, and these are their test scores: 20%, 80%, and 90%. Which one's the outlier? 20%. Isn't that substantially smaller than the other values? Now, once again, do you see why it says it occurs at the end? It's either substantially smaller or larger. So do you see how it's at the end? Okay? Now, this is why, so outlier means it can make your data look like an outright liar. So here's why. So once again, those are my 3 data scores. And if somebody said to me, you're a good teacher and you can keep your job if your students can average a 70% test score. So let's see, do I get to keep my job with these 3 scores? Let's find the average, okay? So let's find the average. Go. 20%. So 20 plus 80 plus 90 divided by 3, right?
You're fired.
I'm fired. Now, so if my vice principal came to me, so an average of 63.3%. If my principal came to me, he is not a statistician, he'd say, you're not a good teacher, Ms. Christensen, your students are only averaging 63.3%. I'd say, you're an outright liar, because this person obviously did not study, correct? Wasn't this substantially different than 80 and 90? So shouldn't we really throw out the outlier for that blasted idiot who didn't study? Wouldn't this be a better measurement of what I'm teaching? So let's throw out the outlier. And let's do 80 plus 90 divided by 2. My students are really averaging an 85%. Because isn't this person making my data look like an outright liar? Does that make sense, everybody? So it's because this is so extreme, it affects my measures of central tendency so much. Does everybody see? So this is really why Vivint hires statisticians. They don't think about these things. They don't say, oh, but that's so different, we better throw that out. That's why they hire statisticians. Does everybody understand? So really, I'm a dang good teacher. So I take these statistics to the principal and he'd let me keep my job. All right, so suppose the values 56, 65, 73, 59, 98, 65, and 59 are the data for the situations below. Would you discard the outlier? Explain. So if we were dealing with water temperature of a lake at 7 locations, and we had these temperatures, which one, first of all, is the outlier? 98. That's substantially larger, right? So let's say that we wanted the water to be in the cooler range. Would we really worry about it that much in A? Or for the most part, are we going to be okay? Right? We wouldn't worry about it that much. Let's say that you were going ice fishing and the water has to be this cold. So would you worry about it, the 98? Not really, right? It's very unlikely that we're going to have to deal with such a high water temperature. In B, though, it says the number of customers in a restaurant each night in 1 week. So these are the number of customers in the restaurant each night in a week. Isn't that 98 going to stand out to me? Was that a Saturday night? Was that a Friday night? Well, we need to consider that, right? If it was on Friday night, wouldn't we suspect that, yeah, that might happen again? Right, everybody? So we wouldn't throw it out for this one. So does everybody see how to just kind of analyzing whether you should worry about the outlier or not, depending on the situation? Okay, sweet. So do 4 through 5, do 12 through 13. Cleanly. So number 12, let's say you guys are hired by the government, you're a statistician, you've gone to college, okay? They hire you, the government hires you, and they give you one of their studies. You're looking at the government's old folks home, and they know that certain things need to happen for certain age groups. So they come to you as a statistician, they're not going to do the math, and they say to you, all right, so here are the age groups. So they say to you, so what's the average age group that we are seeing in our old folks' homes? What would you say? On number 12. 76.2. Now you chose to throw out the outlier. So that 23-year-old in the old folks' home, aren't they an extreme? Aren't they an outlier? So they must be one of the people that have maybe had a stroke at a young age or something, right, everybody?
Yeah.
So would you consider that in the data set? If they're probably not, right? That's an outlier. So you'd say, we have an average of the average age of your people in your old folks' home are around the age 76, right? Everybody. Now what if I said to you, what's the most, or what age do we see most? What would you say? 76, isn't that your mode? Okay. All right, sweet. Sounds good. Okay, so, great. Moving on. Okay, so now we need to talk about range. So range. The range of a data set is the difference between the greatest and least values. So what's your ranging between? What's your values range between? So if you think about it, from 1 to 6, isn't it 6 minus 1, 5? Isn't it ranging between 5 things here? Does everybody understand what range is, okay? So once again, the range of a data set is the difference between the greatest and least values. If you order the data from least value to greatest value, the median divides the data into 2 parts. So looking right here, let's find the median, okay? So we're going to go through and just think about this. So we're going to learn some new terminology here. So our median, I'm going in 1, 2 on this side, going in 1, 2 on this side. Isn't the median in between here? So let's quickly find that. Go. Don't you take those? Divide by 2. Add them, divide by 2. What do we get? 3.5. So isn't that our median of our whole data set?
Yeah.
Now, so we've done that. It says the median of the whole thing divides it into 2 parts, which is true. We have this lower part, ding ding, ding ding ding, and we have this upper. Oh no, just ding ding right here. Sorry. The lower part is these. Oh, sorry. Just a second. Isn't the 3 in our lower part, since 3.5 is the middle? Is everybody good with that?
Yep.
And our upper part would be 4, 5, and 6. Is everybody comfortable with that? There's our upper part. Okay, sweet. Now it says the median of each part divides the data further. So now we're going to find the median of the lower half. Now we're finding the median of the lower half. So let's see here. In 1, 1, isn't this the median of our lower half? Okay, sweet. So this is our other median. The median of the lower half, and then let's find the median of the upper half. 4, 6, so isn't this the median of our upper half? Okay, so you can divide it into 3 medians. The values separating the 4 parts are called quartiles. So we have 4 sections here, 1, 2, 3, and 4. It's splitting this up into quartiles. So this is actually quartile 1. So the median of the lower half would be quartile 1. The median of the whole thing is quartile 2, and the median of the upper half is quartile 3. So if I said to you, find Q3, wouldn't you just go through this process, find the median of the upper half? Okay, sweet. Now it says the interquartile range is the difference between the third and first quartiles. So interquartile range. So now we're talking range of the interquartile. So these are the quartiles. So the interquartile range would be this minus this, because wouldn't that be the range from Q1 to Q2? So you do Q3 minus Q1, so that would be 5 minus 2. Does everybody understand that? Okay, so what was our range of the whole thing? Range means what your data set is between. Between what values? 6 minus 1, guys, that's the range of values we're looking at. Does everybody understand that? So 6 minus 1 is 5. That's how we find the range of the whole thing. So we range between 5 numbers here. Questions on interquartile range. Did you write down anything? Because if you didn't, and you come to me on the test and say, I don't know what interquartile range is, I'll say, where's your notes? It's Q3 minus Q1. Interquartile range. Quartile 1, you should be having notes on this, right? Quartile 1 was the median of the lower half. Quartile 2 was the median of the whole thing. Quartile 3 was the median of the upper half. Are we all comfortable with that? Okay, so looking at this, we've got to work really quick. It says compare the data sets, compare the inches of waterfall between these 2 cities below. So we're looking at St. Petersburg, the number of inches of waterfall, and Key West, Florida. So let's go through and find each of these things so we can compare here. So St. Petersburg, so St. P, okay? So we, first of all, should probably put this in order from least to greatest. So you guys, you need to help me out. We need to get through this really quick. So what's my lowest value? 62. Next. Next. 64, right? 68? Okay.
70.
So 70, 74, 80, 88, 80 what?
84 and 84.
No, 88. Sorry.
Okay, awesome. So now we can go through and answer these questions. Oh my gosh. Okay, so we crossed out all of these.
There's no 8 of them.
So we have everything. Were you guys all helping me out?
Yes. We're good.
Okay, so let's find the mean. Go, go, go. Find the mean. Add those up, divided by the number. Mean means average, right? So what's the average rainfall for St. Petersburg? And that's X bar. Mean means X bar. So you tell me what X bar is. Go. You got 75? So the average waterfall for St. Petersburg, 75 inches, okay? All right, sweet. Now let's find the mode. This one's quick. What is the mode? Which means what happens most in St. Petersburg?
86.
86. Is there any others?
64.
So it's either 64 or 84. Oh, but there's 3 of them, right? So we would say no mode. That statistically that is not a, we have too many modes. Does that make sense? So we would say there's not really a mode here. Are you sure? I remember there being a mode, I thought. Is there an extra thing in there?
No.
We're good? So we would say no mode. Okay? And then median. I want the median of the whole thing. Median of the whole thing. So isn't that quartile 2? To find the median of the whole thing. So in 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So then isn't it between those two? Okay, go. What is it? 76 is correct. So the median, Q2 is 76. What's Q1? Isn't that the median of the lower half, what I have highlighted? So that would be, oh no, with this too, right? Because it was in between those, right?
It is 70.
So let's see here. We go in 1, 2, 3, and 1, 2, 3. Oh, it's between those two, right? So add those up, divide by 2. What's right? 66 is quartile 1. So then what's quartile 2? Wouldn't that be starting from here? 1, 2, 3, and 1, 2, 3. So it would be those two divided by 2, right? 84. Okay, so Q3 is 84. What's our range? Where does it range between?
86 minus 62.
Yep, 86 minus 62.
24.
24 inches. So there's a range of 24 inches. Does everybody understand that? So it's either raining this or this, but there's a difference of 24 inches in between the lowest and highest range. Does that make sense? And then our inner quartile range would be Q3 minus Q1. Right? 84 minus 66. Okay, good. So we would do this on the other side and then we would compare the data sets. I'm not going to do the other side, right? Do you guys understand? So then we could say, like, for example, let me just tell you, if we were to go through and do this for this side so that you guys can see how you compare, this side would have come out as a mean of 79.1. The mode would have been 82 and 87. And then the Q2 would have been 80. And then Q1 would have been 73.5. Q3 would have been 85.5. The range is 18. And the inner quartile range is 12. So this is how we would look at this statistically, guys. So let's see. On average, which city has the most rain? On average, guys. Doesn't that mean average? Guys, you can't just... It doesn't matter if you can find median and mode. It matters if you can statistically determine what it means. So, which city has on average more rain? Okay, awesome. My next question is, which one has most consistent rain? Where is it mostly the same? Key West, right?
Key West.
Our range is 18 and 12, right? Inner quartile range. So it changes less in Key West, right? It's more consistent. Does that make sense? Okay, so it's more consistent in Key West. It's definitely bigger jumps over here in St. Petersburg. Does everybody understand how to statistically analyze? Okay, do this problem. And come to a conclusion. Just because you can find the mean, median, and mode doesn't mean you can come to a conclusion correctly. Go. if you think about it, why do we care about our range and interquartile range? So range means the difference from the lowest to highest, right? So what is the interquartile range if we're really looking at how consistent, be the more accurate range to compare? Because you're not looking at the extremes, right? You're looking in the middle what it ranges between. So that's why we really like interquartile range. It's a better range to say, okay, we're ranging between these values. So that's why we do interquartile range. Okay, sweet. So hopefully you came to a conclusion. So now we've got to talk about box and whisker plots. So a box and whisker plot uses the minimum and the maximum and the medians, Q1, Q2, Q3, to display the spread of the data. Okay, so we use a box and whisker plot to describe spread. So you have to just know these things. Minimum, maximum, Q1, Q2, Q3. So wouldn't Q2 be the median overall?
Yeah.
Right? Isn't that what Q2 is, guys? So this would be the overall median. And then think about it. This would be from here to here. Q1 would be the median between the minimum to there, right? So this would be a median. And then from Q2 up to the maximum, this Q3 is the median there. So this shows the spread. So look at this picture. Isn't my data pretty evenly spread out? Yeah, right? It's pretty even. The box and whisker plot doesn't look skewed. Does everybody understand? So a couple things to note. On a box and whisker plot, the minimums create the whiskers and the max creates the whisker. And then the box is created by Q1, 2, and 3. Is everybody comfortable with that? Okay, now your calculator will just do it for you. You just have to know how to do it. So calculator's out, quick. So this is how you can type it into your calculator. So let's just all do this. So first of all, so you'll hit, so I'm going to pull up my calculator just a second. Let's just do problem number 8. Let's make a box and whisker plot. Now we can do it by hand, right? But then let's just do it with our calculator. So everybody, look at number 8 on the worksheet. Here we go. We're going to make a box and whisker plot. Now, if we were going to do it by hand, we'd have to put the data in order from least to greatest, but your calculator will do it for you. So here we go. So you go to Y. So the first thing we'll do is go to the stat key. Then into edit. And then in list 1, you can't have anything typed into list 2, so delete anything in there. Anywhere but list 1. Now in list 1, we're going to put in our values. So 2, enter. 8, enter. 3, enter. I missed it, but it's okay. And then 7, just put them in. Go. You have to hit delete. It doesn't clear. Everyone should be putting them in. Okay, will somebody read these off so I can get these in quicker? We're at 32, enter. The first 32, then read them to me. 30, enter. 5.
7, 32, 4, 11, 13, 11, 14, 10, 12, 13, 15.
10.
14. No, there's no 14. There's a 14 after the 11.
So 10, 12. I need to add in a 14. 14. What else?
13, 17, 15.
Are you paying attention to what I'm typing in? Okay. So I have the right data points?
Pretty sure.
Okay, so now this is the hard part, okay? So now everybody, we have our stats into list 1. Now you'll hit second y equals. Do you see where it says stat plot? So you'll hit second y equals into stat plot. Now go to number 1. Our plot is turned off right now. We have to go into plot 1. Second stat plot. So go enter. Why is it doing that? It's like clicking. Okay, hit enter into plot. You need to turn it on. Hit enter. Now look, it shows you the different types of graphs. So we want to go over to the box and whisker plot. Now you can do a box and whisker plot with the extremes, the outliers not put in the box and whisker plot, or with. And we're going to do with for right now. So then I hit enter. So then I'm going to enter through. We're getting our data from list 1. So we're getting our data from list 1. And then frequency of 1. Okay. So enter. Okay. So now you'll go to window. Now your window has to be a good window. So our X min means how far down X is left and right, right?
Yeah.
So what's our lowest value in here? 2, right? So we want to at least be able to see in our X window 2. Now what if it was 1,000? Wouldn't we change it to like 900 and 900 so that we could see to 1,000 on the X? Does everybody understand? So my window's going to be at 1, enter, and then my X max. If I don't put the right max, then I'm not going to be able to see the whole thing. Okay, so what's the highest value? Roughly 32, right? So I'm putting in 40. Then I can see between 1 and 40. Our X scale means what do you want to do, what do you want to jump from, in what tick marks? I'm just going to do 1s on this, right? But if they were huge numbers, I would go with like 5s. Does that make sense? Jump between 5s? Does that make sense? Tick marks? Okay, and then our Y min is how far down on the Y-axis and up. With that, I think negative 10 and 10 would be okay. Doesn't really matter with Y, as long as we can see how our Y scale, you'll always keep 1. So now you'll hit graph, and notice how on accident I have another thing being graphed at the same time. You could go into Y equals and clear it out. So that was my regular graph. Does everybody understand? So then you hit graph. Look, there's my box and whisker plot made for me. Okay, now look, if you go second trace, so second trace, oh, actually just trace. So go graph, hit trace. Now it will give you, the median is 10.5, right? Now look, if you scroll over, it's Q1, there's our min. Q1, Q2, Q3, and our max. So you could draw your box and whisker plot, right? Does everybody understand? Okay, so drawing your box and whisker plot.
So where do you go
After you type in appropriate labeling. So we have a box and whisker plot for number 8. It looks somewhat like this. We draw it as much to scale as possible, right? This is 32, right? This is Q3, which is at 15. This is our median, which is at 10.5. This is 6. This is 2. Right? What do you mean I did it wrong?
It's on the other side.
It's skewed on the other side? What do you mean?
It's skewed on the left.
Like you're saying it's more over here?
Yeah, it's like that on the other side.
Okay, so, but you get the idea, right? I'm just drawing a rough sketch. Okay? So draw it right. If this was skewed more in the middle, then that's good. Okay, so then this would have been, you'll want to label like this. Min, this is Q1, Q2, Q3, and max. So what if I said, what's the interquartile range? Couldn't you easily do it? And whatnot. Okay, sweet. What if I said, what's the median? A box and whisker plot will tell you. Does that make sense, everybody? And then min and max. So if I said, what's the range? You do 32 minus 2. Interquartile range, Q3 minus Q1. Okay, so this is what I need you to finish for today. Do not cross anything out. We have to do the full worksheet. But we'll finish it up for Bell Quiz tomorrow. So you need to do tonight 8 through 9 and 14 because that's just box and whisker plots.
It's